Assalamu alaikum. Welcome to lecture 21 of Software Requirements Engineering CSE305 and in today's lecture we are going to continue our discussion on the specification process. If you guys remember the last lecture, we started talking about the functional requirements and also we started our discussion on the non-functional requirements, and because we are talking about the specification process, so it is important to understand how we specify these requirements. And as I have said in the last lecture, that why there is so much importance given to this particular process of specification, because it produces one of the most important work product, that is the software requirement specification document. And in the last lecture we started off with some examples of how can we specify functional requirements in a better manner, and we looked at some examples of badly written functional requirements, and we also saw that how we can put some more detail into it, how we can split multiple requirements when written together, and then those requirements can be more understandable and they can be more clear. Following that, we started our discussion on the non-functional requirements, and often people find it really hard to specify non-functional requirements, and it is for the obvious reasons. So at times we say that these are quality constraints on the product or on the functionality of the product. So the definition or the division between functional and non-functional, it is not always that clear. So we try to differentiate that, how we can differentiate between a functional and a non-functional requirement. And if you guys remember from our discussion on the scenario-based modeling, where we specifically talked about use case text, and we saw that there was a specific section when we were writing the use case text which was of performance or the special requirements, and we said, and we looking back at that example of the ATM cash withdrawal, we saw that we put a special requirement that each transaction should be processed within a certain amount of time. Now that particular transaction is a transaction which is related to the performance, or it puts a constraint on the performance of the system. So we call it a non-functional requirement. Another important thing that we looked upon yesterday was that it depends on the amount of detail and how we specify requirements which differentiate between a functional and a non-functional requirement. For example, if we say that no unauthorized person should have access to the data. Okay, now this requirement, if written in this particular fashion, it seems like a non-functional requirement, because we are saying that because it concerns the safety and security of the data that is to be stored within the system. Whereas if we write this requirement in a fashion and we say that each authenticated user should have a proper login and password which he should use to log in into the system to access the data. Now this requirement becomes a functional requirement, where we are saying that our system should have this functionality of authentication, where the system should allow the users to submit a login and password, and based on that, on the authentication information, it lets them log into the system. Now, so we say that depending on the detail of and how the requirements are specified, we can differentiate, okay, whether this is a function. And so a non-functional requirement, it can become functional if we can translate that particular constraint into the functionality of the product. Following that, we looked at different types of non-functional requirements, which included the performance requirement, reliability, safety, usability, interface, and there are lots of different types of requirements. But the important thing that we discussed in last lecture was classification of these non-functional requirements, and it is very important to understand that which type of non-functional requirement put what type of constraint on the resulting system. So now I would like to emphasize on that a bit more, and so we will, again, the main topic in our lecture today is non-functional requirements. We will look at how we derive non-functional requirements. We will look at how we specify non-functional requirements of safety critical systems. But before we get to it, I'm going to talk about that classification of non-functional requirement, because I think this is very important that we understand the difference between these different classes of non-functional requirements, and it helps us in specifying non-functional requirements in a better manner. So this is a very generic classification of non-functional requirements. So we say there are three different classes. We have process requirements, we have product requirements, and then we have external requirements. So and process requirements, they concern with the process of making the product or of making the system. So the process of process of delivering the product to the client, process of implementing the system, and then there are any standards. So for example, there is a certain ISO standard that the client wants you to follow, or your organization is CMMI level 3, so you have certain standards that you need to follow. So any requirements which are put, which constrain your way of doing something, are related to the process requirement. Then we have these product requirements, and product requirements, they specifically put some constraints on the behavior and functionality of the product. So they include the usability requirements, they include reliability, safety, efficiency, performance, and capacity requirements. Then finally we looked at one of a very interesting class of these non-functional requirements, which is called the external requirements. And there is a distinction between this requirement, and we always say, and we looked upon that these external requirements, they are normally not written as shall or the system should have. Because why that is the case? Because they are kind of external things which our system should always respond to. So our system cannot be in existence, our system cannot be called functional if it does not satisfy these requirements. So what are the different types of external requirements? It can be legal constraints, it can be any economic constraints, or it can be any interoperability constraints. So let's look at some of the examples that we also looked in the last lecture and try to just recap and figure out, okay, what is a process, what is a product, and what is an external requirement. So these are few examples of the product requirements, and remember, these are all different types of product requirements. So we have usability, reliability, performance, capacity. These are all which are constraints on some behavior or functionality of the product. They are all product non-functional requirements. So let's look at these examples and try to figure out that which category they would fit in. So the system service X shall have an availability of 999 out of 1000, or 99%. So we are saying that our system might have lots of functionality. So we are saying there is a certain functionality and it should be available 99% of the time. Now that is a requirement which is related to the product, and it is specifically related to the reliability aspect of the product. So we are saying that if somebody requests to use this service 1000 times, it should work 999 times. So that is one example of a reliability non-functional requirement. System Y shall process a minimum of 8 transactions per second. So again, this is very similar to that ATM transaction response requirement. And so this is again a performance requirement where we are saying that our system should respond to every transaction within 8 seconds. Then the next one is the executable code of system Z shall be limited to 512 kilobytes. This is a space requirement which specifies the maximum memory size of the system. Then another example is the user or the request for the user's PIN shall be issued within 5 seconds of the card being entered in the card reader. This is again an example of a performance requirement. And how we actually get to know, that what are the constraints on the behaviors of my system. And again, I would suggest that when we are doing analysis and elaboration, if we put some more thought into it, and if we do some more brainstorming, multiple requirement analysts, they sit together and they talk about it, that okay, these are the functionality that our product should have, or this is how my product would behave depending on the user interaction. Are there any constraints that we want to put on how my system is going to behave? So when you think of your system in that fashion, then you will be able to identify most of these performance and most of these reliability requirements. So these are few examples of the product requirement. Now let's look at some examples of the process requirement. So as I said, process requirement are constraints on the way you do certain things. For example, what are the things that you are doing? You're implementing the product. So if there are any constraint put on how you are going to implement the product, that will be related to process non-functional requirements. Similarly, if you have any constraint related to how you deliver the product to the client, that would be a constraint on your process of delivering. So that is again a non-functional process requirement. So let's look at few of these examples. So the development process to be used must be explicitly defined and must be conformant with the ISO 9000 standards. So we are saying that the development process, it has to conform to particular standard, particular ISO standard. Now if let's say if your organization is CMMI level 2, level 3, now you have lots of these standards. For example, the first key process area of CMMI level 2 is concerned with requirement management. So what that would mean, that your process of gathering requirements should conform to that particular process. So if there are any constraints put upon you by a process, And if you have to conform to certain standards, then these are all non-functional process requirements. And at times these are kind of implicit, because you already know that you are a CMMI level 2, level 3 companies. But if in case the client requires something to be delivered in a certain fashion, you have to explicitly mention that. The system must be developed using the XYZ suite of case tools. So you're also specifying that which kind of tools you have to use to actually develop the system. And then management reports setting out the effort expended on each identified system component must be produced every 2 weeks. So here it is suggesting that you have to produce reports which actually would show that how much effort is spent on different modules that you're working on. Moreover, a disaster recovery plan for the system development must be specified. So these are all related to the way we are going to build the system. So all these kind of examples, all the constraints on the way how you are going to do different things when you are developing this product are related to the process. And these are process non-functional requirements. So finally we have external requirements. So now a couple of examples include that medical data system, the organization's data protection officer must certify that all data is maintained according to data protection legislation before the system is put into operation. Now, as I mentioned in our last lecture as well, that one of the main concerns with all the e-health, all the people who are working in the e-health area is maintaining security of electronic records, because nobody wants the patient record to become public. So there are lots of legislation on data protection. So any such system, it needs to ensure that the data is protected before it becomes operational. So that is kind of an external requirement, or that is an external legislation which limits the way your system should behave. Similarly, another example is specifically of the application domain. For example, you are making a train protection system, and in that you have to implement a certain application or domain specific formula for deceleration of train. So how you would specify it, that the time required to bring train to a complete stop, complete halt or stop is computed using the following function. So you actually give the deceleration function as well. So if you look at these two particular examples of external requirements, then it becomes very obvious that if we are making any one of these two systems, either the train protection system or the medical data system, if I do not have these two, if my system does not conform to these two external requirements, it will never be functional. So for example, if my medical data system does not conform to the legislation put by the authorities on data protection of patients, it will never become operational. Similarly, if the train protection system does not implement this particular formula, which is requirement by the client, or which is requirement by that particular application domain, then the protection system would be useless. Nobody is going to use it. So a specific formula is given, and all these terminologies you need to explain it. So for example, if you are the requirement analyst, you go down and you get this formula, you need to get more explanation about it, and you need to know how we are going to calculate these different things and what would be the values of these particular parameters. So these are the three main classes. We have process non-functional requirements, we have product non-functional requirements, and we have external non-functional requirements. And so the reason why I put so much emphasis on these classification of requirements is that if we understand the process requirements of our organization and of the client's organization, then the process requirements, they are very easy to identify. And if we, as a requirement analyst, if I know the application domain, or if I know the environment in which the product is going to be used, and if I develop that kind of familiarity with the system or with the system's environment, I can very easily identify the external requirements as well. Or at times, client would be very obliged to actually give me those external requirements. So now the important thing is to identify those product non-functional requirements. And as I have said that during analysis and during the elaboration phase, when we are trying to analyze the elicited requirements or elicited scenarios, if we put some more thought into it, we can easily identify those special requirements which can later then be classified as product non-functional requirements. So these are the three main classes of non-functional requirements. Now let's look at that, how do we derive these non-functional requirements? And as I've been saying that these NFRs are difficult to express. It's not very easy to identify these and specify these non-functional requirements, because at times I've said that most of these things, when user actually would tell you about these things, then they would all be qualitative statements. So you need to actually you need to actually figure out that, how you will quantify it. So you need to actually ask the client, what do you mean by good, or what do you mean by acceptable? So for example, the client says that the response time of the system should be acceptable. Now you need to actually quantify it, that what does acceptable mean. So you need to ask him that, okay, how do you want the system to behave? So if he says acceptable, you need to ask that what is acceptable to you. For example, is it acceptable that the system responds to each one of your transaction within 5 seconds, 8 seconds, 10 seconds? So you need to actually figure out that what should be the system response time, and you will specifically then write it as a performance requirement. So that's why they are difficult to express, because normally people would, if you are eliciting requirements, people would talk about these things in a qualitative fashion, and then later on you realize, okay, this is not a verifiable or testable requirement, so how I am going to quantify it? So there are a number of issues contribute to this problem of expressing non-functional requirements. And what are these issues? There are certain constraints are related to design solution that is unknown at the requirement stage. Okay. So for example, there are lots of things which are maybe related to reliability and these kind of things which are related to design, which are design specific issues which you cannot actually express in a lot of detail at the requirement stage. There are certain constraints are highly subjective and can only be determined through complex empirical evaluations. Non-functional requirements tend to be related to one or more functional requirements. Non-functional requirements tend to conflict and contradict. This is something that we talked about yesterday as well, that at times you might have scenarios where you have a performance requirement which directly conflicts with the safety or security requirement. For example, let's say you put lots of encryption on your data, and when you have to access the data, then all that decryption, it takes too long, and the transaction actually then takes long. So it does not satisfy the performance constraint because you have those security and safety constraints on your on the data of your system. Now, and we talked about it, that how do we resolve such situations? So we said that we always, again, we do ranking, that which feature is more important to the client, which would serve the business goal of the client well, and then we say, okay, this is the more important one, so let's worry about that. And then there are no universal rules and guidelines for determining when non-functional requirements are optimally met. So again, lots of functional requirements for the functional requirements we do lots of testing. There are some examples of non-functional requirements for which we do testing as well, but at times there is no actually guideline. For example, there are lots of interface requirements which are being mentioned, and it doesn't matter how hard you try to quantify them, but it is always, it will always, there is no specific criteria or there is no specific rule based on which you would say, okay, my system actually meets all those interface requirements. Okay. So, so it's kind of based on the judgment that you actually figure out that your system is actually fulfilling all those non-functional requirements. So stakeholders, they also have concerns, so what are these concerns? Stakeholders normally have a number of concerns, and all these concerns, they are typically non-functional. Some of the examples include that the critical business objectives, essential system characteristics, for example, security, safety, performance, functionality, and maintainability. And all these vaguely defined user concerns, they relate to these non-functional requirements. As I was talking about this in our last slide as well, that whenever user is going to express about the system, then all the things that he is actually going to talk about would relate to qualitative non-functional statements about the system. So it's your job as an analyst to actually figure out that how you are going to quantify them, because as we have seen that there are a number of reasons why we say it is very difficult to express non-functional requirements, and because we said that they are subjective terms and they can be conflict. So if you quantify them, then we can be in a position to actually resolve these problems. So let's try to figure out the relationship between the user needs, concerns, and non-functional requirements. Now, user needs can be classified into the function, performance, and change. The user concerns can be related to the functionality of the product, that the product should be easy to use, there shouldn't be any unauthorized access, and the likelihood of failure should be reduced or minimized. Now, if we try to figure out that all these user concerns, which type of non-functional requirements actually conform to these particular user concerns, then the ease of use relates directly to the usability non-functional requirement, because we are trying to say that the product should be, or the system should be easy to use, and that is how we define the usability non-functional requirements. That that we want the system to be as usable by all the end users as it can be. Then unauthorized access, it relates to the security requirements. Then the likelihood of failure, it relates to the reliability of the system. Then if we look at the performance needs of the users, then what are the performance concerns of the users? That resource utilization should be minimum, the performance verification should be there, and ease of interfacing should be there. So resource utilization, it relates to the efficiency, non-functional requirements. Performance verification leads to verifiability type of non-functional requirements, and ease of interfacing, it is related to the interoperability non-functional requirements. Then the third kind of user needs are the change needs. And what are the user's concerns? That ease of repair, if anything goes wrong with the system, it should be easy to repair. If the customer or the client wants something to be changed, it should be easy to do that. Ease of transport and ease of expanding or upgrading the capacity or the performance. So ease of repair, it relates to the maintainability non-functional requirements. So the client wants the system to be maintainable. Okay, so if there are any problems, it should be easy to maintain. Then ease of change, the system should be flexible. And then ease of transport, system should be portable. Then final is ease of expanding or upgrading capacity or performance, it relates to the expandability. So it is very important to, if we know that these are the main needs that the different users would have, it is important to identify those needs, and it is important to talk to different end users and different stakeholders and try to identify, okay, what are their concerns with the system. And we need to actually ask them specifically. For example, the example of likelihood of failure, if they are using the system, what according to them is acceptable likelihood of failure. Okay. So because we are going to specify a non-functional reliability requirement based on that, so we need to actually know what is the reliability that the client expects from my system. So the idea is that you go and talk to different people who have these kind of concerns with the system and try to figure out, okay, what is acceptable to them. So what is a concern? It is a way of expressing critical, holistic requirement. Okay. Concerns may be broken down into sub-concerns and finally into specific questions. Questions act as a checklist to ensure that specific requirements do not conflict with the global priorities. So how we are going to deal with these concerns? Because the idea is that as a requirement analyst, what we are trying to understand is that we have a user who is going to tell us what he wants in the system. Okay, and I am, let's say, a requirement analyst, and I will go and talk to the user, and we will be discussing different functionalities of the product. But when the client is actually telling about different functionalities of the product, he would also have some concerns. Okay, and those concerns, at first, they would not be that quantitative, and they would be generalized, holistic requirement statements, or these would be some concerns that the client would say, okay, I want this particular function, but it should not have this. So it might be a statement like that. So what you need to do then, that you need to identify from those concerns, you need to look at those concerns and see if there are any sub concerns that you can identify. So try to narrow down the problem as much as you can, and then you try to make some questions out of it. And these questions would give you an indication, because as we said that lots of these non-functional requirements, they would conflict and contradict with each other. And the way of resolving that conflict or contradiction is that we rank these non-functional requirements and we try to evaluate that which of the non-functional requirements are more important to the client. So for example, the business goal or the business objective, and we also need to relate these non-functional requirements to the overall business goals of the client. So we need to figure out that, okay, this is more important to the client and this is in line with the business goals. Okay. So it is important that the concerns that the client shows, we try to figure out that whether they contradict with the overall business goals or not. So how do we actually decompose these concerns? So for example, one of the main concerns, so if you look at, there are two typical examples. One is of the safety and the other is of compatibility. So let's first look at these, safety concerns. So the main concern is safety. We talked with different end users, and all of them, they had this particular concern of safety. And within safety, there were three sub-concerns. Okay. First one is related to collision. So this is specifically for that particular train protection system. So related to that bigger concern, safety, there were three sub-concerns. That one concern was, which is related to safety, was collision. The other was derailment, and the third one was personal accident. So God forbid there can be three kind of incidents that can happen with a train on the track. There can be a conclusion, derailment, and a personal accident. Now these are the things which nobody wants. Okay. So people have concern about them. So how do we actually try to figure out that, and how we try to prioritize them, and how we try to actually identify the questions out of these concerns? So for example, if we look at this derailment concern or derailment sub-concern, so this is our main concern, and these are the sub-concerns. So how can this derailment happen? Excess speed for track conditions. Now, speed limits are put on trains for a number of reasons. Okay. For example, when the train is going through a portion of the town which is kind of crowded, then the train speeds are reduced. Similarly, depending on the condition of the track, the speed is reduced. And then, so this is one reason, that excess or overspeeding for a certain type of track, and if the track is damaged, then this derailment can occur. So how our system should respond now? So let's say we are building this train protection system, and we have identified the concern that the clients, they have this concern of safety. Okay. And we have identified that there are three kind of sub-concerns related to safety. One is collision, the other is derailment, and the third one is personal accident. So now we are trying to figure out that, we are making this particular system. So what our system can actually do for these particular client needs or these particular concerns. So we are saying, okay, derailment can occur if there is overspeeding, depending on the type of the track, and if the track is damaged. So these are the two main reasons. So we are trying to understand, okay, how my system should behave. So let's say in related to the excess speeding or overspeeding, we say that the system must be able to detect and avoid excess speed. Okay. So for example, our system should be able to detect that if the track conditions are not good, then our system should be able to detect that and reduce the speed automatically. Okay. And the question then becomes is that, and that is how we actually try to figure out, and we try to quantify them. That now becomes a very direct question for the client, that under what conditions can excess speed cause derailment? Okay, so that is one question. And what does excess speed mean in reality? Now these two are, this is very important, that as a requirement analyst, I need to completely understand what is the main concern of the client. And I know that client have these concerns, and that is why he has come to me. He has not only come to me so that I can produce a system that is functional, but he wants me to produce a system that actually answers his concerns as well. And at times, if there is a competition between different solutions, then it comes to who actually satisfies the most of the concerns of the client. And one of the concerns that people have for these train protection systems is safety, and there can be multiple kind of incidents or things that can go wrong. And one of this is derailment. So there are two particular reasons of derailment. We have identified that excess speeding on a track that is not that is in poor condition, and track damage. So we are saying that, okay, how our system should respond to if there is if track conditions are not good. So we have two questions then. That what does excess speed mean? So for example, does excess speed mean that the train is going at 70 kilometers per hour, or is it 50 or so? So what is excess speed meant for particular type of track conditions? And we need to actually figure out as well that what is meant by poor track conditions. So we need to identify those kind of situations that, okay, whether if the train gets too bumpy, does that mean that the track conditions are poor, or what does actually meant by poor track conditions? Similarly, a question related to the track damage is what information about the track damage is required and how is this provided? So that is another question that we need to answer when we are specifying these non-functional requirements. Similarly, let's look at this other example, which is a compatibility concern. Okay, and in terms of compatibility, generally the client or the user, they want the product to be compatible with the software, with the hardware that they already have, and with the physical environment in which the product is going to be deployed. So in terms of the software, let's say there are three main sub-concerns. We are saying the execution environment, we are saying timing, and we are saying the interface. Okay, so in terms of interface, we are saying that does a requirement need data that isn't available through the HST interface? Will our requirement affect the performance of the existing software? And execution environment, we are saying that system must execute in the trusted ADA execution environment. Can this function be provided on the existing execution environment? So what is important from us to actually take from this particular slide is that normally these non-functional requirements, they are user concerns. Okay, and user would have these concerns about quality of the system. So they can be related to safety, they can be related to compatibility, they can be related to reliability, they can be related to security, and they can be related to performance as well. So what we need to do is, in order to develop our understanding or in order to specify these non-functional requirements, is that we need to identify, okay, that this is the main concern that we have actually seen that different users or different end users or different stakeholders have talked about. So we need to figure out, okay, what are the sub-concerns which are related to this main concern, and we try to get to those questions, those specific questions which are going to help us in specifying these non-functional requirements in a quantitative fashion, and that is the main goal here. So there is a way how we go from a concern to a non-functional requirement. So directly a concern cannot become a non-functional requirement, because we need to develop certain form of understanding. It is actually very similar to the way we talked about that we analyze the scenarios or the user stories that client has told us about the product, and those are translated into the functional requirements because they give us understanding about functionality, behavior, information domain of the product. Similarly, the concerns which are actually the concerns about the quality of the product, and they relate to the non-functional requirements, we need to develop or we need to do some analysis on that as well. So we need to actually figure out, okay, that how this concern can be translated as a non-functional requirement in my software requirement specification document. So that for that purpose we do this concern decomposition. So let's look at this now let's look at this goal-based derivation. So we have seen that one way of deriving these non-functional requirements is that we identify the concerns, then through the concern decomposition we try to figure out that what are the non-functional requirements. Another way of identifying or deriving non-functional requirement is goal-based derivation. So it relates to the non-functional requirements to the goals of the enterprise. So we know why the enterprise or why our client, they want this particular system, or what are their enterprise goals. So we try to relate those non-functional requirements to those bigger goals. So goal-based NFR derivation is a three-step approach. The first is identify the enterprise goals, decomposition of the goals into sub-goals, and then identify non-functional requirements, which would actually help an organization achieve those sub-goals. So it is kind of similar to that concern decomposition, but because they are goal-based, so what we have is, the first thing is that we have these enterprise goals. So once we identify them, we can sort of identify, okay, what are the sub-goals. So we identify the sub-goals, so sub-goal 2 and sub-goal 3, let's say, and then we try to identify the non-functional requirements which would help this particular organization in achieving these sub-goals and thus the overall goal. So let's look at this example of goal-based derivation and how we identify non-functional requirements through this goal-based decomposition. So let's say the bigger goal is that visualize air traffic scenarios, and this this bigger goal, it motivates this sub goal, which is the sub goal says the system should perform in real time. So we want the system to perform in real time, and there are two non-functional requirements which are related to this sub goal, and one is that display radar data in real time, and the second one is the display must accommodate all the data from the scenario. So the display should be such that it actually shows all the data from the scenario. So what do we mean by all the data? So we are saying that it should display 100 tracks, it should display 100 meteorological plots, it should display 200 vectors, and it should display 500 table symbols. So again, these requirements, they are related to a particular system that we are talking about. But the important thing is that we identified the goal, and then we identified the sub-goal. So the bigger goal is that you want to visualize the air traffic scenarios, and then we identify the sub-goal. That sub-goal was related to that the system should perform in real time, and we identified two non-functional requirements which would help achieve that sub-goal. Number one was the system must accommodate all the data that is relevant to a particular scenario. So we have said that it should display all the data. So the next thing is to know that what is all the data. So we are saying that there are four things. It should display all 100 tracks, it should display 100 meteorological plots, display 200 vectors, display 500 table symbols. Now, if you look at these non-functional requirement statements, then they are actually quantitative now, because we have now actually specified that in order to achieve this sub-goal, I wanted the system to show all the data that is relevant to the scenario. So not only that I have identified all the data, but I have actually also quantified it, and now I clearly know what kind of information my system should display. So the second non-functional requirement, which was related to that sub-goal of the system should perform in real time, was display radar data in real time. So that was again a non-functional requirement, but that was not very quantifiable or very specific. So we are saying that aircraft position should be displayed in less than 3/16th of a second of the radar sweep period. So again, this has become very, very specific now. So we have actually quantified it that we wanted the system to actually display real-time radar data. So we have actually said that how much time it should take to actually update the display. So this is another way of actually getting to non-functional requirements. We saw that concern-based decomposition, and we have looked at this goal-based derivation. We were saying that we identify the bigger goal or the enterprise goal, and then we sort of identify all the sub-goals, okay, related to that overall business objective or the business goal. And we then sort of try to identify, okay, what are the non-functional requirements which would help us achieve this particular sub-goal, and then we try to quantify them. So we will keep on going down to a stage where we have these quantified statements. So what are these? Because one of the qualities, if you guys remember, one of the qualities we said about requirements is that they should be testable. So how can we make these non-functional requirements testable? And this is a very big problem with non-functional requirements. Why? Because stakeholder may have vague goals which cannot be expressed precisely. As you can see, you know, for example, looking back at this particular goal, which says that visualize air traffic scenarios. Now, if you just specify this as it is in your software requirement specification document under non-functional requirements, then you will never be able to satisfy the client, because it doesn't matter what you actually show him or what you actually tell him, he can always say, no, this is not what I wanted. Because you have not actually identified that, you know, one of the things that he wanted was that the system actually should display real-time data, and when he wanted to see that real-time data, what was the frequency with which he wanted the plane position to be updated, and secondly, what kind of information he wanted to actually visualize. So it is very important that you get rid of this vagueness from those statements. And that is why we have talked about this derivation, and as I said, we'll keep on doing this derivation until we are able to quantify these statements. So vague and imprecise requirements, they are problematic, and non-functional requirements should satisfy two attributes. They must be objective. So this is very important, and that is where the skill of a requirement analyst comes into play, that all these concerns and all these goals. So these are the two things that we have talked about today, mainly, that we said that, you know, all users, they have concerns, and generally organization or people, they have bigger goals. And these goals and these concerns, they are always vague statements, and at times these things, they are subjective. Why they are subjective? It is very similar to, you know, those conflicts in functional requirements, because people are coming from different viewpoints. Now, for one person, performance would mean a totally different thing, and for another person it would mean a different thing. So we need to get rid of that subjectivity from a requirement when we are developing a system, because we need to set a benchmark, and our system should be good enough to actually achieve that benchmark. So we need to have, so whenever we are specifying these non-functional requirements, one of the attributes that these requirements should have, that they should be, or they must be objective. They must be objective. The second is they must be testable. Second is they must be testable. So we need to use measurable matrix. And you know, having said that, it is not always possible to express non-functional requirements objectively, but this is what we should strive for. So we should put in as much effort as we can to specifying non-functional requirements in an objective and a testable fashion, because it would mean that when we go and show our system to the client, then because if the statement is objective and testable, then it would mean that we will be able to actually figure out that whether my system is actually achieving those qualities or not. But if the statements are subjective and they are not testable, then, you know, it will not bode well for you when you go to show your system to the client, because then the client can always say, okay, no, I actually wanted something totally different. Okay, so that you certainly you don't want that. So what are the examples of some measurable matrix for these non-functional requirements? So for example, whenever we are talking about performance, so generally when we are developing a system, so performance is always translated, or it can be measured using these matrix. So one of the metric for performance is the process transaction time, and the second one is response time to the user input. So whenever performance is a concern, we should actually figure out whether the requirement is testable or not by these matrix. So if we have identified the transaction time, or if we identified the response time, then this is something which we can actually measure. So the reliability property, it can be expressed in terms of two matrix. And what are these matrix? Number one is rate of occurrence of failure, and the second one is mean time to failure. If we objectively, because what these matrix would do is it would bring objectivity, and it would mean that my reliability requirements, they will become testable. So if I have mentioned these two matrix from the client, that what is acceptable value of this, you know, occurrence of failure for him, and what is the mean time to failure that the client expects from this product. So if when we make the system, we can actually test our system, and if my system satisfies these two matrix, that then we have actually met this reliability non-functional requirements. Similarly, in terms of availability, so probability of failure on demand. Now the customer might have different availability requirements. So we need to actually ask the client that, okay, now what do you mean by availability? And when we are specifying this availability requirement, we should use this particular metric to actually express this non-functional requirements. And when we talk about size, then size is always measurable. So for example, the client says that I want the executable code to be as small as possible. Now again, this is not an objective or a testable statement. So if we specifically ask him the size or the range, that okay, the product should be in this size, and if we ask in terms of kilobytes, then it would mean that my statement would become testable, and it would become objective as well. Similarly, in terms of usability, so the matrix that are used for usability to make a non-functional usability requirement testable are time taken to learn 80% of the facilities, and number of errors made by users in a given time period. So we can so you know, a statement like my system should be usable, or it should be easy to use by different users, they are a very bad statement. Why? Because they are subjective, and secondly, they are not testable. But if we write a statement that, you know, the time taken to learn 80% of the functionalities is 5 hours. So this statement is actually objective and it is testable. Similarly, we can also say that, you know, once number of errors produced by users in 2 hours is less than 5, so you know that is again, it becomes objective and it becomes testable as well. And similarly, a couple of more examples. So for the property of a product, non-functional property of the product, that is robustness, one of the metric that can be used is time to start after system failure. And similarly, portability can be expressed in terms of number of target systems. So for example, you know, the client says that the system should be portable, so we should actually ask him that what are your target systems. Okay, so whenever you are specifying non-functional requirements of the product, we have said that each non-functional requirement, it should have 2 attributes. Number 1, they should be objective, and number 2, they should be testable. And how we can ensure that my requirements are testable? By using different metrics to express these non-functional requirements. So now imagine that these are all the non-functional requirements that you have to mention about the product. So if you use these metrics to express these non-functional requirements, it would actually mean that all the non-functional requirements, they are now testable and they are objective. So the use of matrix in expressing non-functional requirements is very important, because it would mean that you would have set of requirements which you can test before actually showing it to the client. Okay, and this is something very important, and that how we identify the requirements for critical systems, and specifically these non-functional requirements for critical systems. So systems, first of all, it is very important to figure out that how do we define these critical systems. So systems whose failure causes significant economic, physical or human damage to organization or people, they are classified as critical systems. There are 3 principal types of critical systems. Number 1 are business critical systems, number 2 are mission critical systems, and the third one are safety critical systems. So what are business critical systems? Where failure of the system causes significant economic damage to a business, and an example of such a system is an airline reservation system. So imagine that an airline company, it only reserves through that reservation system. Now if that system is down, then it is going to miss lots of reservation, and there would be lots of economic loss to that particular organization. Now the other category was, the other type of critical systems was the mission critical systems. So where the failure of the system means that some mission cannot be accomplished. An example of such a system is control system on a spacecraft. Now imagine the spacecraft is going somewhere and the control system is damaged, then you know the mission would be a failure certainly. So that is a mission critical system. The third type of these critical system is the safety critical system, where the failure of a system endangers human life or causes significant environmental damage. An example of such a system is a control system for a radiation therapy machine. So these are the 3 the main types of critical system. We have business critical system, we have mission critical system, and we have safety critical systems. So why it is important to or why I'm actually emphasizing more on non-functional requirements for critical systems is because that at times the failures to those systems, they are a result of more of not being able to satisfy those non-functional requirements than those of functional requirements. So that is why it is very important to very carefully analyze and evaluate the non-functional requirements for critical systems. So the principal non-functional constraints which are relevant to the critical systems, they include reliability, they include performance, they include security, usability, and safety. So these concerns, they are really important for those critical systems, because we have said that if the system is going to fail, then it will cause a lot of damage to economic, physical, or to human lives as well. So it is very important to carefully figure out that what are these constraints for critical systems. So now we have identified the types of critical systems. So let's look at why it is important to express these non-functional requirements for a critical system even more carefully than for any other system. Because it is said that a failure of a critical system may result from a failure to meet a functional requirement. It can happen, but more often it results from a failure of the system to satisfy some non-functional constraints on its operations. So it is so we say that, you know, obviously if the system is not functioning properly, then it would fail. But more often there are lots of examples that can be found that the system was not able to actually meet those non-functional constraints, and that is why the system failed. So it is very important to identify that what are those constraints, what are those non-functional constraints for safety critical systems. So normally we say that these are 5 main constraints. Number 1 is reliability, then we have performance, security, usability, and safety. So let's look at reliability first. So when we talk about reliability, these are the constraints on the runtime behavior of the system, that how we want our system to behave during the runtime. It can be considered under 2 separate headings. Number 1 is availability. Is the system available for the service when requested by end users? So this is really important, that in terms of safety critical systems, system should be available all the time. Okay, so whenever a user wants a certain facility, it should be available to the user. The second one is the failure rate. How often does the system fail to deliver the service expected by the end users? So if we are talking about a critical system, then we need to express reliability in these 2 terms, that what is the availability of the different services that the system is providing, and what is the failure rate. Reliability requirements, they can be expressed quantitatively, and as we talk about it in our previous slides, that we can use different metrics to express requirements more quantitatively and in a testable fashion. So availability may be specified in terms of the time when the system is unavailable for service. For example, 3 minutes in 24 hours. So normally when, you know, for example, you know, you might have often seen that the backups are usually planned for weekends. Okay. Now, if that is the case, why is that is the case? Because you want the system to be available all the time. And if the system is taking backup, then it would mean that the certain functionalities are actually not available. So the reason why these things are planned for the when there are lesser amount of users or lesser amount of load on the system, because we want the system to ensure availability to all the users. Similarly, the acceptable failure rate may be specified in terms of the rate of occurrence of failure in a given time period, and or the mean time between system failures. So these are the 2 things which can be used: MTTF, which is known as mean time to failure, and ROCOF, which is occurrence of failures in a given time period, or rate of occurrence of failures given in a given time period. So it is very important to express these non-functional reliability constraints of critical systems quantitatively. Similarly, talking about performance, these are the constraints on the speed of operation of a system. So type of performance requirement are response requirements, throughput requirements, and timing requirements. So what are these response requirements? They specify the acceptable response of the system to the end user input. For example, it might be specified that the system should respond to a user request for service within 2 seconds, and we have talked about it, and the importance of this actually increases for a critical system. Okay, so for a critical system, it should ensure that it always meets that particular response time. And the throughput requirements, which specify the amount of data which must be processed in a given time. For example, it might be specified that the system must process at least 10 transactions per second. Now, it is very important to differentiate between a critical system and any other system. Now, for example, if I just make a very simple website, which is just my personal web page, now if it's not available or if it's not responding, if somebody is trying to visit that, it doesn't really matter, because it is not a critical system. It is not going to cause anyone any economic, physical, or any human damage. So, but whereas if we're talking about the train protection system, or if we are talking about that maybe airline reservation system, now for that the response time and the throughput time, it is really important. And my system and the importance of mentioning the performance requirement for a safety critical system is way more than for any other system. So that is why we need to use those metrics that we have talked about when we are expressing these non-functional requirements. And the final performance requirement is related to the timing requirements, and they specify how quickly the system must collect input from the sensors before it is overwritten by the next input value, or which specify how quickly outputs must be produced for processing by other systems. For example, it might be specified that the system must poll the sensor at least 6 times per second. So this is again something very important. So for example, let's go back to that train protection system example, and let's say we figured out with the help of the client that this is how, through the use of certain type of sensors, we will be able to identify if the track is in poor condition. Okay, and so it is very important that as soon that we should not miss any input from those sensors. So we should have some timing limit or some timing constraint put on that how quickly my system should actually poll those sensors, or what is the frequency of polling those sensors, because those sensors would have new values very soon, so we don't want to miss any critical value. Okay, so we need to very carefully specify those timing requirements as well, and it is very important for critical systems that these requirements are mentioned as quantitatively as possible. So we are going to end our discussion. On non-functional requirements here, and we are going to quickly summarize what we have done today. And in our next lecture, we are going to continue our discussion on specifying the non-functional requirements for safety critical systems. So in our lecture today, we started with our discussion on specifying non-functional requirements. We started our discussion today by looking back at what are different classes of non-functional requirements, and we saw that there are 3 different classes of non-functional requirements. We have process requirements, we have product requirements, and we have external requirements. Specifically in today's lecture, we talked about that how we derive these non-functional requirements, and that is the critical bit, because the non-functional requirements, they are expressed by the users in 2 different ways. There are concerns that the users have, and then there are goals that the user wants to achieve, or for which the enterprise is actually looking for this particular system. So there are 2 techniques which can be deployed to identify these non-functional requirements. Number 1 is the concern decomposition, and in the concern decomposition, we talked about that we have a bigger concern. For example, safety is the concern. And we looked at the particular example of the train protection system. We said that safety is a concern there. So how we will identify these non-functional requirements? So we said that safety is my bigger concern, and I identify some sub-concerns. That one concern related to the safety of the train is that the train should not derail. Okay, and there should not be any personal accident. So that is the concern, and I then have to identify that how this derailment can occur, number 1. So what I would do is that I would try to identify, okay, that derailment can occur in 2 ways. If the train is overspeeding on part of the track which is not proper, or there is any track damage. So there are 2 possibilities: the overspeeding one, and the other one is that the track is damaged. Now there are 2 things here. That number 1 is overspeeding on a track that is not in good condition. So as an analyst, now I have 2 questions. That number 1 is that so I have 2 particular questions now. That what does excess speed mean? Number 2 is how the system would identify poor track condition. So now these are the 2 important questions that I have figured out, and based on the answers of these questions, I would be able to translate this concern of the client into non-functional requirements. So that is one way of deriving non-functional requirements. The other way we talked about is through goal decomposition. So now an organization can have a goal, and we saw the example that an organization wants to visualize the air traffic. So that is the bigger goal, that visualize the air traffic. Okay. Now one of the sub goals of that visualization is, and we talked about this, that if we just specify this particular statement, that visualize the air traffic, in my software requirement specification document, then whatever I will produce, the client can always say this is not what I wanted, because we did not carefully decompose that goal into sub goals and try to figure out some quantitative or objective statements about this bigger goal. So we said that one of the sub goals which can be related to this visualized air traffic is that the client wants to see data in real time. So there are 2 things here, that what does real time mean? So one concern is that how frequently should the plane position be updated based on the radar input, and the other is that what kind of data the client wants to be displayed. So we need to identify that what are the different kinds of data that the client wants to actually see on the screen. So if we do this goal decomposition and we try to figure out that how our system can help client achieve this particular goal, we can specify these requirements in an objective and testable manner. And this is something very important that we talked about when we discussed these concern decomposition and goal decomposition, that all the non-functional requirements that we specify, they should be testable and they should be objective. And how we can ensure that the requirements are testable? By using different metrics. For example, in terms of reliability, we said that the matrix that can be used is mean time to failure or availability of the system. So if we use these metrics to specify these non-functional requirements, it would ensure that the requirements I have expressed, they are testable. And then finally, towards the end of the lecture, we started talking about specifying these non-functional requirements for safety critical systems. So finally, we talked about specifying these non-functional requirements for critical systems, and we saw there are the three main type of critical systems. We have business critical system, we have mission, and we have safety critical systems. And then this is something very important for you guys to remember, that more often than not, the failure of these critical system is a result of system not responding to or not meeting those non-functional constraints. So it is very important in case of critical systems to properly figure out that what are those non-functional constraints on the product, and there we sort of identified that there are 5 main constraints, which are reliability, performance, security, and usability. So we are going to we started talking about reliability, we looked at the performance, and we said that how we can quantitatively express or specify them. We are going to continue our discussion in the next lecture about specifying these non-functional requirements for safety critical systems. But that is it from today's lecture. Take care and Allah Hafiz.